In this video, we will look at the solution stoichiometry practice sheet, where reactions are being performed in solution. The first question says how many grams of iron 3 hydroxide will be produced if 0.890 liters of 2.3 molar barium hydroxide reacts with excess iron 3 chloride. There's no equation written here, so the first thing that we need to do is write out the balanced chemical equation. So iron 3 hydroxide is being produced, so that means that it's definitely a product in this reaction. And we are reacting barium hydroxide with excess iron 3 chloride. So I'll start with my two reactants. Barium hydroxide, barium's plus 2, and hydroxide is OH with a -1 charge. So barium hydroxide is BaOH2, reacting with iron 3 chloride, so iron Fe with a +3 charge. Chloride is Cl with a -1 charge, so iron 3 chloride would be FeCl3. So there are my first two reactants. Then I need to figure out the products. This is going to be a double displacement reaction. It tells us that one of the products is the iron 3 hydroxide. So I'll start with that one, iron 3 hydroxide. So FeOH3. And then my other product is going to be barium bonding with chlorine. Iron bonded with hydroxide, barium is going to bond with the chloride. So I'll need to re-crisscross for that one as well. Barium has a +2 charge, and then chloride is a -1 charge. So barium chloride would be BaCl3. Now we have the chemical equation, but we have yet to balance this equation. So we'll start out by balancing. Next up we will balance. I see right away that hydroxide, there's 2 on the reactant side and 3 on the product side, so I need to make an even number of hydroxides in order to balance. So I'll put a 2 in front of iron 3 hydroxide, which allows me to put a 3 in front of barium hydroxide. Then my barium is out of balance, 3 bariums on the reactant side, so I need to put a 3 on the product side. And that gives me 9 chlorines, which actually doesn't... I actually made a mistake here. That's why it doesn't make sense. Chlorine actually here should have a subscript of 2, not a subscript of 3, because when the 2 crosses down, we get a 2 there. So I did make a mistake there, and that I realized that when I started to balance, and I had 9 chlorines on the product side, and I realized that I was only going to be able to have 2 times 3, so 6 chlorines on the reactant side because of that iron here. So that clued me into my mistake. So go ahead and fix that. So now I have 6 chlorines on the product side, and I can actually fix that by putting a 2 right here in front of iron 3 chloride, which also causes 2 irons to match the 2 irons over here. So now I have a balanced equation. And this is a great example of a time where there was something that just didn't feel right. And so when something just doesn't feel right like this, it's always a good idea to go back and double check your crisscrosses, which is exactly what we did here, and realize that we've made a simple subscript mistake that we were able to fix before completing the entire problem incorrectly. So now that we have the balanced chemical equation, we can start doing our stoichiometry. In this problem, instead of giving us the number of grams of our reactant, it gives us the volume and the concentration of the reactant, of the barium hydroxide. And so the word "of" in math usually indicates multiplying, which in this case is what we're going to do, because we know that 2.3 molar means that we have 2.3 moles of barium hydroxide in every 1 liter. And so we can use that as a conversion factor to take our liters into moles and go from there. So we'll start out with that 0.890 liters of barium hydroxide, BaOH2. And then we will use our molarity, 2.3 moles in every 1 liter, to convert to a number of moles. Once we're in moles of barium hydroxide, we will need to take our moles of barium hydroxide, BaOH2, to moles of our new substance. And the problem is asking us how many grams of iron 3 hydroxide. So we need to go to moles first of iron, FeOH3. And now that we are in moles of our desired substance, we can go ahead and take that right out to grams. Our moles to gram conversion. 1 mole of FeOH3, and I really should have the substance here, FeOH3, FeOH3. 1 mole of iron hydroxide, if you add up the molar mass, 3 oxygens, 3 hydrogens, and an iron, is about 106.9 grams. Then our mole-to-mole ratio is going to come from the balanced chemical equation. So FeOH3, there are 2 of those in our balanced equation. And then barium hydroxide, there are 3 in our balanced chemical equation. So it's a 2 to 3 mole ratio. Now we have this entire problem set up, so all that's left is to multiply and divide it out. So 0.89 times 2.3 times 2 times 106.9 divided by 3 gives me a final answer of 145.88. But before we box in that answer, we should round to appropriate sig figs. And if we take a look back at the problem, we have 3 sig figs in our volume and 3 sig figs in our molarity. So our answer should also be rounded to 3 sig figs. And this 8 is going to make the 5 round up. And so instead of 145, it's going to be 146 grams of FeOH3. And now we can box in that final answer.